All right, so we are starting in order of how we learned these laws. So the first one we learned is the ideal gas law. You know that you have to use the ideal gas law because you will see these variables given to you in the problem. So you'll have pressure, you'll have volume. The one that really gives it away is when they give you information about moles. Like if they give you information about moles, more than likely you will use the ideal gas law. So first step is to write down the formula. So PV is equal to nRT. All right, now I have to identify the variables that they did give me in the problem. So let me go look for pressure. So pressure is equal to what? How many moles of nitrogen will be contained in 3 liters of nitrogen at 1.2 atm? This right here is my pressure because atmosphere is a pressure unit. So 1.2 atm. Next one is V. V is volume. So I have to look for something that says like liters. So how many moles of nitrogen will be contained in 3 liters? Boom, there it is. 3 liters. Next one is N. N is for the, number of moles. However, this problem is like, how many moles? So you don't know N. N is what you are solving for. Next up, you got R. R is a gas constant. The most common one you will use for this unit, and honestly for the rest of chemistry, is the one at the top. It all depends on the units that the problem gives you. So this one works with atmospheres, this one works with kilopascals, and this one works with millimeters of mercury. This, again, is the most common one. In this problem, we have atmospheres. So this is the constant that we'll be using. So 0.08206. And lastly, we got T. They give us, T is temperature, and they give us temperature in Celsius. What you have to remember is that temperature should always be in Kelvin for all of these problems. So, how do you turn degrees Celsius into Kelvin? You add 273, and that will equal Kelvin. So if my temperature is 324 Celsius, I'm going to add 273 to equal Kelvin. Let me just take my calculator. 324 plus 273 is 347. No, that's not right. Hold on. 324 plus 273 is 597. That seems more accurate. So 597 Kelvin. All right, so now I have all of my variables identified except one. That's what I'm solving for. So now I can plug this back into my equation. So pressure is 1.2 times volume is 3 is equal to N, we don't know, so I'm just going to leave it as N, times R, which is 0.08206, times T, which is 597. So now I'm going to start multiplying these numbers out. 1.2 times 3 is 3.6 is equal to N times 597 times 0.08206 times 48.99 approximately. Then I need to solve for N, so I need to divide both sides by 48.99 divided by 48.99. 3.6 divided by 48.99 is approximately 0.073 is equal to N. Again, N is the number of moles, so your final answer should be 0.073 moles. Don't stress yourself with rounding right now. We didn't learn how to properly round this year. So a good rule of thumb is to always just round at the very end of a problem. I didn't do that, but you should. So if you're rounding to like the second decimal, that's usually good enough. But yeah, don't worry about rounding. If you are interested though in learning about the proper way of rounding, look up on YouTube significant figures. This teaches you how to properly round for all of your science classes in the future, just if you're interested. All right, next up, we got what is, let me move this paper, 125 degrees Celsius in Kelvin. Pretty simple stuff. You just need to use the formula degrees Celsius plus 273 is equal to Kelvin. So if degrees Celsius are 125, plug that in, 125 plus 273 is equal to 125 plus, oh man, I messed up, 125 plus 273, 398. 398 Kelvin, and that's my answer. Super easy. Next up, we got another one of my ideal gas laws. Again, if they give you some information about moles, typically that's an indicator that you should use the ideal gas law. Write down the formula. PV is equal to nRT. Now I need to find my variables. I need to find P, V, N, R, and T. Let's read the problem. A balloon is filled with 12 moles of oxygen gas. Right off the bat, I am given N, my number of moles. So I have 12 moles. The balloon can inflate to hold 6,500 liters. This gives me a pretty good indication that this is a volume unit. So I'm just going to write it right here for now. Calculate the pressure in atmospheres. So I am trying to find the pressure. I don't know the pressure. When the balloon is at a temperature of negative 42 degrees Celsius. So this is my temperature. Again, temperature in these problems should always be in Kelvin. So I need to turn this temperature into Kelvin. And I do that by adding 273. So negative 42 plus 273. And now I need to open up my calculator. That's the same thing as saying 273 minus 42. 231. 231 Kelvin. So my temperature is 231 Kelvin. R is always a constant. Again, it is always going to be the same as up here. 0.08206. It's a constant. It's always the same. Okay, so now I just have to plug in my numbers. So I don't know what P is. I'm solving for P. My volume is 6,500 liters is equal to N, which is 12, times R, which is 0.08206, times T, which is 231. All right, so now let me multiply these numbers out. P times 6,500 doesn't change just yet, but this side does. So 12 times 0.08206 times 231 is 227.47. If I divide both sides by 6,500, I will be solving for P, which is what I want to do. Divided by 6,500, and that is approximately P is equal to 0.035. Because I am solving for P, P is pressure, and it is in atmospheres. I need to remember my units. Atmospheres. And this is my answer.